Hello, Clarence. Okay, good morning. Deal is a deal. This is the part of the deal. And so I'm going to answer you the question of why the arch of Kisra is not symmetrical. So I think that the first thing we have to know is the difference between what is a parabola and what's a catenary. We can search in the Wikipedia, especially the parabola, and it goes back to the 4th century before Christ. It belongs to the family of the conics. The great difference is a catenary. So catenary comes from the Latin word, or in Spanish is cadena, chain. So it's the shape of the chain when you hang it from, if you take from the ends of the chain, the shape of the chain, this is the catenary. That was said a lot of things about the catenary. Even, for example, Galileo talked about the difference between the both of them, but nothing relevant. So the big guy who understood, or at least what we know so far before this class, or this explanation, is that what is the relation between the catenary and the arch. And the big guy is Robert Hooke. Robert Hooke. This English guy, the English guy, proud of himself. You can see here, the Robert Hooke holding the chains from his hands in this portrait. And in the portrait you can see all the inventions and discoveries of Robert Hooke, but the main one was the catenary. So he wrote, you can see here, this was published in 1675. Look, carefully to the content of the publication. It's just a paragraph, no? He said, the true mathematical and mechanical form of all manner of arches for building, with the true battlement necessary to each of them, a problem which no architectonic writer had ever yet attempted, much less performed. And then the solution is A, B, C, C, C. So what happened? So he wrote the answer but encrypted. Why? Because somehow he had to pay his bills, and he was making money with this. In his designs, he was an engineer, he was an architect, and so he kept the secret. So after his death, his executor revealed the content of that. And the content of that is this. So the meaning of all this bunch of letters is ut pendet continuum flexile sit extabit contigium rigidum inversum. But that means that what you hold in your hands, this shape, if you turn it upside down, this is the true arch. So, and after that, many guys use all this, this knowledge. You can see, for example, Gaudí was the master in using this knowledge. So what hangs, if you turn it upside down, you get everything in compression. And that was so important, because if you get everything in compression, what happens is that if an arch is fully in compression, then the cross-section has a constant value of stress. And it's so important because you don't have bending. Well, anyway, but for me was a discovery, Kisra. Kisra, if you see Kisra, it smells to a catenary. Actually, let's draw a catenary and a parabola inside Kisra. You can see here, in the continuous line is a parabola, and in dashed line is the catenary that go through these 3 points that are marked, P1, O, and P2. So it looks like that Kisra is more a catenary than a parabola. But let's do a step beyond. And I'm going to show you some experiment that one of my PhD students from the University of Italy and Swiss.
Step 1. Single chain catenary model. Step 2. double chain catenary model. The blue chain models the walls, and the red chain models the arch. Third step, additional loads. On both sides. Last step, application of the differential settlement.
You have here a catenary, and you can see that, comes from the middle of the support to the middle of the other support, and it is not a catenary. But if you consider that the walls are thicker, and you have two chains, one heavier and the other lighter, you can see that somehow the span wider, and you have is closer to Tazkirra. If you go a step forward and consider the weights, or the difference between the weights of the arch and the weight of the chain, so you really are reproducing the real weight of the arch, you see that it's really close, especially the left part, although the right part is not the same. So we published that with Professors Gil Martin and Fernandez Ruiz from the University of Granada, and Mark Ashane from the University of Santa Clara in California. And well, we suspected that somehow there were settlement, maybe during construction, maybe after construction. We didn't really know that. So actually we planned an expedition to go there and to measure or see or investigate the rows of bricks. But at the end, having a dinner with my friend Matti and his student Amir from the Metropolitan University of Oslo in Norway, and they told me, well, they revealed to me the existence of Ferdowsi, the Persian writer, and his great work, the Shahnameh. And in the volume number 8, there is the history of the construction of Tazkirra. And it was really, really a masterpiece. So there was a figure called Fargan, and Fargan was the designer of Tazkirra. So the Shah wanted a palace, and he opened a bid or a contest, no? And many engineers, designers appeared, and he chose one. His name was Fargan. And we can read, said the Shah, accept this contract at my hands and heed these my instructions. I require a building such that although my sons and the race will dwell therein for many years, it will not fall, and it will resist rain and snow and sun and everything. So Fargan, let me see. So the designer or the artist or whoever, Fargan started to build this palace. And at some point, he said, well, Shah, I cannot continue. We cannot continue. We have to wait. And then the Shah said, well, what the hell is this? I mean, you want more money? So, well, at some point he said, he was not able to continue. And the Shah did not understand his reasons. So at some point he demanded some commissioners from the Shah. We can read that in the Shahnameh. And it says something like this. Well, it says this, no? So the Shah appointed men as he was asked, who went and made an inspection to the walls. The artist brought silk, and he turned it, and from the silk he did a rope, and then he measured from the ground to the top of the walls, and gave to the keeper and said, well, keep that into the treasure of the palace. And as Shahnameh said, that night he disappeared and no one saw him. So the Shah said, well, where is this guy? You know, I mean, he just left. And the Shah tried to find people to finish the work, but no one was so there to do it. And then after 5 years or 4 years, he appeared and said, Shah, please hear me before you kill me. And look, you know, go for the measure that you have in the treasure. And they detected a differential settlement of 3 meters. So then he said to the Shah, well, you know, with this settlement, the world should be now in ruins and you will kill me. So please now let me finish that. And after 70 years, he finished the work that we can see. So in this small video, you can see my students doing the 3 cases. One with 1 chain, the other with 2 changes, you know, one heavier for the walls. Another, you know, more precise approach is with the additional weight. And the third one is having account the settlement. So, and you can see in the last picture that with the settlement is almost perfect. You know, imagine, I mean, it's more than 1,000 years old, so it's almost perfect. The left side is perfect. The right side is just a little bit different in the top, no? But still is really amazing. So what we can conclude here is that Fargan had the notion that the catenary was the true arch, no doubt. The only way to do a design is by hanging models, and he did hanging models. And he took account of the abutments, and he took account of the deformation before construction. And he knew that the shape depended on the geometry of the abutment. So we can say by no doubt that Hooke was not the first. You know, I mean, he in his writing, when he claims that that he was really the first, that no one did anything like that, was not true. Fargan knew exactly what he was doing. And I think that Fargan deserves a place in history of a structure. I mean, he was really a structural engineer, and he deserves to be known. Okay, hope, Clarence, that was enough. And now is the second part of the deal. See you. Bye.